In this video, we're going to start section 2.8, and I believe this is the last section for chapter 2. And in this, we're going to cover the distance and midpoint formulas, and then talk about circles and their formulas. All right, let's get started. First, the distance formula. You've seen this before in a couple other math classes, geometry for sure, probably Algebra 2 and Algebra 1. The distance d between 2 points, x1, y1, and x2, y2 in the rectangular coordinate system is d equals, here we have our big square root, and under that square root we have two quantities squared and added together. The first one is the difference in the x's, x2 minus x1, and we square it. And then we add to that another quantity, difference in the y's, y2 minus y1, quantity squared. If you get the x's and y's backwards, if you do the y's first, that's going to be fine because you're adding them anyway. If you get the coordinates within the parentheses backwards in one of them, it's not going to matter because you're going to be squaring it anyway. So they're always going to turn out to be positive. So sometimes using this can be a pretty forgiving formula. To compute the distance between 2 points, find the square of the difference between the x-coordinates plus the square of the difference between the y-coordinates. The principal square root of this sum is their distance. And this is all just based on the Pythagorean theorem. A squared plus b squared equals c squared. Come down here to this picture. Here's a, b, and we'll call the hypotenuse c. Well, if we find the distance between these x-coordinates, that's the length of this side of the triangle. And if we find the distance between the y-coordinates, that is the up-down here, this side of the triangle. So if we set up our Pythagorean theorem, a squared plus b squared equals c squared, a here is the difference in the x's, x minus x. And then b is this side of the triangle, or the difference of the y's, y2 minus y1, quantity squared. And that's equal to the hypotenuse squared, c squared. Well, if we want to find c, we would take the square root of both sides. And we're just saying this c, this distance here, is the distance between the points, which also happens to be the hypotenuse of the right triangle. So this is just a derivation of the distance, or I mean the Pythagorean theorem, which didn't belong to Pythagoras anyway. Example 1, using the distance formula. Let's find the distance between these 2 points. Express the answer in simplified radical form, and then we're also going to round it to 2 places. So let's just remember the distance formula here. We got our big radical, and then we're going to subtract our x's and square that quantity, and we're going to subtract our y's and square that quantity. All right, our 2 points are -1, 4 and 3, -2. First, let's do our x-coordinates. I'm going to subtract right to left. Again, it really doesn't matter. Under here, I'm going to have 3 minus a -1, and we're going to square it. And then subtract my y's, -2 minus 4, quantity squared. All right, so under the radical here, we're going to have a minus and negative. That'll turn into a positive, and that'll add up to 4. 3 plus 1 is 4, and we'll square 4 and get 16. And here we -2 minus 4, we add the opposite, so that turns into a -6, and we square -6 and get positive 36. And then we add what we have underneath the radical up, and we get the square root of 52. So we have it in radical form, but not fully simplified yet. There is a perfect square hidden in 52. And we can break that 52 up into that perfect square in another number and simplify the radical. Well, the perfect square hidden in there is 4. 4 times 13 is 52. So 52 can be written as the square root of 4 times the square root of 13. And we know the square root of 4 is equal to 2. 2 square roots of 13. And if we punch that into our calculator, we get approximately 7.21. And let's check that out here. I included a graph in the notes. -1, 4, we go to -1, 4, here's this point. And then 3, -2, over to 3, down to -2. And this is also, another way to illustrate that this is just the Pythagorean theorem. Ooh, that wasn't very good. If I just connect those dots, here's the distance that we're finding. And again, this is just, a way to look at it by the Pythagorean theorem. So underneath our radical, we had one of the sides was 4 and we squared it, and the other side was 6 and we squared that. Well, here's our side length that was 4. This would have been our A to square for Pythagorean theorem. And then this side was length 6. Oop, and that was also our B. So this 2 roots 13 is the length of the hypotenuse of this right triangle. Oh, and I guess we do have a picture included up here. Yeah, same thing I drew. All right, over to the midpoint formula. Consider a line segment with these endpoints, x1, y1, and x2, y2. The coordinate of the segment's midpoint is this. We add up the x coordinates and divide by 2, and we add up the y coordinates and divide by 2. To find a midpoint, take the average of the 2 x coordinates and the average of the 2 y coordinates. So remember, to find an average of 2 things, you add them up and divide by 2. So we're going to take the 2 points and find their average, find their midpoint. And it looks like we have a great question down here. Do I add or subtract coordinates when applying the midpoint and distance formulas? The midpoint formula requires finding the sum of the coordinates. By contrast, the distance formula requires finding the difference of the coordinates. It's easy to confuse the two formulas. Be sure to use addition, not subtraction, when you're applying the midpoint formula. And I have noticed, in years past, a lot of confusion with students. The midpoint, when you use the midpoint formula, your answer is going to be a point. You have this endpoint and this, or you have 2 endpoints of your line segment. The midpoint is going to be another point. When you use the distance formula, your answer is going to be a length, or a distance between 2 points in the plane. Or you think about it as the length of the hypotenuse of a right triangle. One of them is a length, the other is a point in the plane. So let's try it out. Find the midpoint of the line segment with these endpoints. And I did include a graph. We can check the reasonableness of our answer with the graph. So our formula is x1 plus x2 over 2, comma, y1 plus y2 over 2, close parenthesis. All right, let's plug in our x coordinates. I see a 1 and a negative 8. 1 plus negative 8 over 2. And for our y values, negative 6, negative 4. And we add those and divide by 2. So it looks like here we're going to have a negative 7 over 2, negative 7 halves. And then for our y coordinate, we'll get a negative 10 in the numerator and divide by 2, and that'll be a negative 5. So that looks like our midpoint. And I did include a graph. It's always a good idea to sketch a little graph and check the reasonableness of that answer. So one point was 1, negative 6, and the other one was negative 8, negative 4. And if I connect the 2 dots, and we plot the point that we found here. So this, as a decimal would be negative 3.5, comma negative 5. Well, if I go to 3.5 and down here to negative 5, yeah, it looks like I'm hitting the line, and it looks, we could sort of check slope. It looks like I went down 1 and over 1, 2, 3, 4.5. So down 1, and then there's a half, 1, 2, 3, 4.5. Yeah, all right, just a little way to verify that our answer is reasonable. Yep, and here's the book's illustration, and there's our midpoint. If you find a midpoint and it turns out your midpoint is up here or down here, there might be a small error in your addition or, the plotting of the points. So if you can, always check your solution. All right, now circle. We're going to end this video on circles, and we're going to stick with the most basic circle where we are centered on the origin. But I will introduce the formula for even the circles that are not centered on the origin. So our goal is to translate a circle's geometric definition into an equation. We begin with the geometric definition. So a circle is a set of all points in a plane that are equidistant from a fixed point, called the center. The fixed distance from the center to any point on the circle is the radius. The figure here on the left is our starting point for obtaining a circle's equation. We've placed a circle into a rectangular coordinate system. The circle's center is h comma k. That's just a point in the plane. X comma y is our usual variables for the points in the plane, but because these are special points denoting the center of a circle, we're going to use h and k. We let x comma y represent the coordinates of any point on the circle. So here's our center HK. XY is going to be a point on the circle, and R is the distance between the center and a point on the circle. So what does the geometric definition of a circle tell us about the point XY in the figure? The point is on the circle if and only if the distance from the center is R. We can use the distance formula to express this identity algebraically. So if we look here, it almost looks like the distance formula, doesn't it? X minus x quantity squared plus y minus y quantity squared. Well, that's because this is just the distance formula, but we plugged in h and k for the center coordinates of the circle. And we made it equal to the distance from the center of the circle to a point on it, of course, is the radius. So that's the r. The distance between x comma y and h comma k is equal to the radius. Squaring both sides of this equation yields the standard form of the equation of a circle. So if I square the left side, the radical disappears, and if I square the r, it becomes r squared. So here's our standard form for the equation of a circle. It has center hk, radius r. Our equation is x minus h, quantity squared, plus y minus k, quantity squared, equals the radius squared. And I think I just copied that back up there. So it says here to write the standard form of the equation of a circle with the center right at the origin, 0, 0, and radius 2, and then they want us to graph it. Well, since this might be the first time some of us have seen the circle equation, I'll write it out here. It's a good thing to have memorized. And let's see what we can plug in. Well, we're centered at the origin, 0, 0. So for the h and the k, I'm going to plug zeros in for both. So here we're going to have x minus 0, quantity squared, plus y minus 0, quantity squared, equals, and it tells us that the radius is 2. So we're going to plug in a 2 for the r. Don't forget to square it. All right, here in the first set of parentheses, x minus 0 is just x, and that'll be x squared. Plus y minus 0 is y, and then we square it. And then on the other side of the equals, 2 squared is 4. So that is the equation of a circle that is centered right at the origin with a radius of 2. And then they did want us to graph the circle. So I'm going to plot my center at the origin, and a good starting point is to go up 2 on the y, over 2 on the x, down 2 on the y, left 2 on the x. So there are 4 points, and we're just going to connect those with the best possible circle that we can. Doesn't have to be perfect. Oop, that last little bit is just not acceptable. That's a little better. So there's our circle, centered at the origin, radius 2. I'm sure the book's illustration was slightly better. And there it is, x squared plus y squared equals 4. All right, some practice problems for you. Pause the video, start them up, or do the problems, and fire it back up and check your handiwork. Okay. Checkpoint 1. Find the distance between these 2 points. Express the answer in simplified radical form. Then round to 2 decimal places. Again, our distance formula. D equals big old radical. We subtract our x's and square it, and add to that. Subtract our y's and square that. So our distance equals. Let's see, I'll subtract what the heck left to right this time. X minus x, negative 1 minus 2, and we square that quantity, plus negative 3 minus 3, and we square that quantity. So let's see. First quantity, we add the opposite, we get a negative 3, and when we square that, we get 9. And then the other one, we add the opposite, get a negative 6, square that, and get 36. So we add those up and get the root of 45. And there is a perfect square hidden in 45. And oops, that would be equals. 45 is also 9 times 5. And the square root of 9 is our perfect square, 3. 3 square roots of 5 is the distance between the points. But then thinking about that as a distance doesn't make much sense. If we punch it in the calculator, we can get our approximate decimal. So we can do a little rounding and get that to about 6.71. And there we go. Number 2, find the midpoint of the line segment with these endpoints. And now that we brought this up, I do remember that I forgot to show you something in the example. Oops. I'll point it out here. A different way that I come up to find the midpoint. Again, I just come up with it in high school. It made more sense to me at the time. So let's see. Add the x coordinates. You know, here's our 1, here's our 7. Add them up and divide by 2. And then our y coordinates are 2 and -3. Add those up, divide by 2. So here we're going to get an 8 divided by 2, which is 4. And then 2 plus a -3 takes us to -1. So that'll be a -1/2 for our y coordinate. Now, you know, you use this formula enough. You know, you're adding your x's, dividing by 2, adding your y's, dividing by 2. Most people I know make mistakes getting their x's and the y's. I guess the only way to really mess this up is to accidentally plug a y value in here or maybe an x value in here. So to minimize the chance of doing that when I was in high school, I would just line the points right up. I'd put the first point on top, second point on the bottom, and then I'd just add them. 2 plus -3 is -1. 1 and 7 add up to 8. And then I just want to remember the next step I'd want to divide by 2. Just chop whatever's in these parentheses in half. Half of 8 is 4. Half of -1 is -1/2. So just a little alternate way to think about the midpoint formula. Last one. Write the standard form of the equation. Circle centered at the origin, radius 4. Again, if you've never seen it before, it doesn't hurt to write out the equation. X minus h, y minus k, each of those quantities squared is equal to the radius squared. And because we're going to plug it in right at the origin, this h is a 0, x minus 0 is x, and we square it. And a 0 goes in for the k, and y minus 0 is just y, and we square it. And that's equal to the radius 4, which is squared. 4 squared is 16. So there's the equation of our circle. Centered at the origin, radius 4. They didn't ask us to sketch it, but you know, just an easy way to do that is you just go to an equal distance on each axis. 4 units, ooh, that's not very good. 4 units from the origin. And then just connect those points. There you get the idea. I can cheat. There we go. Much better. There's some homework for you. Give it a try.